Hello, in this example we're going to work a difference quotient problem. The difference quotient for any function is always written this way. It is the function evaluated at the quantity x plus h minus the original function all divided by h. So what does that mean to us? Well, notice that this function notation, f of x equals 5x squared minus 3x plus 1, means that anywhere we see x, we're going to square that number, whatever it is, and then multiply it by 5 and subtract 3 times that same number and add 1. In other words, whatever you see inside of the parentheses is exactly the same as what you should be evaluating inside the function in place of x. So when we say f of x plus h, you should be thinking, oh, let's take x plus h, square that, multiply it by 5, subtract 3 times that quantity of x plus h, and then add 1. So, how is this going to work out? Well, for our difference quotient, we're going to say f of x plus h, which we just told you was 5 times x plus h squared minus 3 times x plus h plus 1, f of x plus h. And we're going to subtract from that the original function f of x, which is 5x squared minus 3x plus 1, all divided by h. So we're going to get this big long fraction right here that we're going to have to simplify. Well, a little bit of work here, it won't hurt anybody. So let's take x plus h squared. Remember that x plus h squared means x plus h times x plus h. And you can kind of do this off to the side if you need to. It's one of those special products that we studied back in chapter 1, chapter P really, with our multiplication of polynomials. We end up with x squared plus 2 times xh plus h squared. Right? If you were to carry out the FOIL method, x times x is x squared. We're going to have x times h plus x times h, so that's plus 2xh plus h squared. So you just want to keep that in mind. That is where we're getting these values. Now, of course, we're going to take minus 3x minus 3h plus 1 when we get rid of these square bracket parentheses over here. Of course, we want to get rid of the square bracket parentheses over here to simplify. So we distribute our negative and we get minus 5x squared plus 3x minus 1. Again, all of this is still over h. Don't forget that you're always reducing a fraction when you do this. So we take that 5 and we're going to distribute it to each of the terms inside of the parenthesis here. To help us simplify one more time, we've got 5x squared plus 10xh plus 5h squared minus 3x minus 3h plus 1 minus 5x squared plus 3x minus 1. Big long fraction, lots and lots of terms. By golly, what do we do? Well, you'll notice that there are some like terms that we can get rid of right away. For example, you might have noticed that 5x squared and minus 5x squared are in the same fraction. You can get rid of them. By subtraction, they cancel out. Same thing with 3x. We've got minus 3x here, we've got plus 3x here. Well, since they're opposite signs, same terms, we get rid of them. And we get plus 1 and minus 1 as well. So look at what we're left with. We've got 10xh plus 5h squared minus 3h, and all of this is divided by h. This is useful for us because in the numerator we note that we now have a common factor of h in each term, and if we use our distributive property to remove it, that leaves us with h times 10x plus 5h minus 3 all divided by h. Since h is now a common factor in the numerator and denominator, we can cancel that, and we're just left with 10x plus 5h minus 3, provided we don't let h actually equal 0. This is the answer we wanted, and so we're done.